Okay.
So first, we'll start with rules for significant figures. Sometimes I will give you in multiple choice questions some questions on how to determine the number of significant figures. So first, the first rule is that all non-zero members are significant. Yani if you have a number with where all numbers are different than zero, okay, then you count all of these numbers as significant. Yani if I give you 33.2 and you want to count the number of significant figures, it's 1, 2, and 3. Okay. Now, zeros between two non-zero digits are significant. So whenever you have a zero placed between any two other numbers, then you will count it as significant. So here, for example, the number 2051, you have a zero, but it's between two numbers, 2 and 5. So we'll count it as significant number. This is why this number 2051 has 1, 2, 3, 4 significant figures. Now, leading zeros are not significant. So whenever you have, if you want zeros at the beginning of a number, you don't count them. So here, all zeros to the left of your non-zero numbers are not counted before and after the decimal point. Okay, so these are called leading zeros. Leading zeros are not significant numbers. We don't count them. So if we have the number 0.54, this zero is not counted. You just say we count 5 and 4. So 0.54 has only two significant figures. However, if I take 0.0032, then in this case, I will also say that these three zeros are leading zeros, so we don't count them. So we just have 1 and 2 significant figures. Another rule is that trailing zeros to the right of the decimal are significant. So here, if you have, let's say, consecutive zeros after the decimal point, okay, then you should count them. They are significant. So when we say 92.00, for us, this is 4 significant figures. However, when we just say 92, this is 2 significant figures. And what is the difference if I tell you 92.00 or I tell you 92? The difference is that, for example, if I give you a measurement, okay, whenever I tell you 92.00, so I have an accuracy. Let's say I'm saying 92.00 millimeters. This means that I am able to measure with my rule up to, or any measurement device, up to 0.01 millimeter. However, if I tell you I'm measuring 92 millimeters, this means that my accuracy is up to 1 millimeter. Okay, so this is how, this is the meaning of having such zeros. This is why we put them, to tell you what is the accuracy of the device you are using. So when I say my measurement is 92.00, this means that I am able to measure up to 0.01 millimeters. However, when I tell you that my measurement is 92 millimeters, this means that I can just measure up to 1 millimeter. Yani when I read, I can read or 92 or 93, etc., or 94. However, here I can read 92.01 millimeter, 92.02, etc. Okay. Now, so this is why it's important to understand that zero does not mean nothing. It can give you a certain information about the accuracy of measurements. Okay. Now, another rule to determine the number of significant, one second. Okay. Now, rule number 5 is the following one. So trailing zeros in a whole number with the decimal shown are significant. So whenever we have zeros, okay, and we already said before that let's say we consider that 0 is a significant number when it is between two other numbers, okay? So we said that if we have 504, we count it. We count our 0. We say that this is 1, 2, 3 significant, okay? However, when we have, let's say, just without the decimal point, if we just say 540, okay, we don't count the 0 here. The 0 will not be counted. So in this case, 540 has only 2 significant numbers. However, if I put 540 dot with a decimal, okay, this means that I want to consider this 0 as significant. Okay, so then I say whenever you have the decimal point close to it, then you say that I will count it as significant number. So I have 540 dot is will give me 1, 2, 3 significant numbers. Okay, so trailing zeros in a whole number with the decimal shown are significant. So placing a decimal at the end of a number is usually not done. We just do it by convention, however, in order to indicate that this 0 is significant, a significant 0. So when I give you 540 dot, then you will count the 0 as a significant number. Okay? And now, if I just tell you 540, so if you have a trailing 0 in a whole number with no decimal shown after it, then it's not a significant 0. So I just count it as, I count here just these two numbers as significant. Now, exact numbers have an infinite number of significant figures. So even if you have an exact number, okay, 1, let's say 1, if you just write 1 in this way, it's 1 significant figure. Okay, if you write 1.00, we said already that all zeros after decimal point should be, so if we have just 1.00 without anything else, so even because they are after the dot, okay, so we should count that in this case. So we count this 0 and we count it as significant. And even if I put 10.00, now after this 0, because you have dot and another other zeros after the decimal, and we said that we count these zeros. So in total, when I put 10.00, this means that I have to take a significant figure 1, 2, 3, and 4. Okay, so if I just say 1, it's 1 significant figure. If I put 1.00, it's 3 significant figures. And I can increase the number of zeros.
إذا كان عنا
yeah
1.003 بيكونوا الزيرو زيرو اللي بالنص significant figure ولا لا؟
أكيد على طول اللي بين النمبرز significant. اوكي، يعني 1.003 لأنه بين 2 significant numbers بنحسبهم. أي متى الزيروز ما بنحسبهم؟ إذا هن هيك، يعني إذا عندك 0.0001 هول ما بنحسبهم. أوكي، بس إذا عندك مثلا 1.003 يعني الزيروز بين 2 numbers بنحسبهم. أوكي، now so here كل هول الزيروز بدنا نحسبهم لأنهم بعد الديسيمال بوينت. اوكي، يعني فينا نلعب بالنمبر of significant figures notation مثل ما بدنا. يعني if we have in order for 1 to indicate that 1 is a number with 4 significant figures بدنا نحط 1.000. okay, now back to the example posed in the rounding tutorial. يعني here if we consider 1000.3, we want to if this يعني this number, if we want to count its significant numbers هن 5 1 لأنه هول الزيروز are between two significant numbers بدنا نحسبهم 1 2 3 4 and 5. Okay, now in case we can play with the way of presenting the number to change the number of significant figures. يعني for example, we know that 1000.3 has 5 significant figures, and 0 between 1 and 3 will be counted as significant figures. Okay, now if we need to drop the number of significant figures to 3 instead of 5, what can we do? What we can do, we can leave the last 0 alone. So if we put for example 1000 point, يعني we don't give the accuracy up to this number, then we count just 4 significant figures. يلي هن ليش بدنا نحسب هول الزيروز؟ لأنه في عنا الدوت point, decimal point. So if we want to drop from 5 to 4, مفروض ال 3 ما بقى تكون موجودة. So we just put 1000 dot. Okay? Now, if you want to count number of significant figure as 1, ما مفروض تحطوا الدوت. يعني إذا بنشيل الدوت قد ايه بيصير ال 1000؟ بيصير just 1 هو significant figure. والزيروز I don't count them. Okay? هلا شوي سائلين الرولز، بس انه just يعني هن rules and just you apply them. فهن عادة بالمultiple choice sometimes they give you a number and they just tell you what is the number of significant figures. And if you just know these rules, you can answer the question. Okay?
دكتور مقولي الزيرو دوت
شو هن الزيرو دوت؟ بس تحط دوت ليك، بس تحط دوت كل شيء زيرو قبل الدوت بتحسبه. يعني إذا أنا عندي 10 دوت بدي I want to count the number of significant figures, I count the zero. يعني بيكون عندي 2 significant figures. بينما إذا بحط لك 10 بس you don't count the zero, you just count 1 significant figure. Okay?
ايه فهمت، بس قصدي مثلا بركي النمبر 0.000 بدل ما اكتب 0 point something بحط 0 دوت لا احسب انه 0 significant figure.
انت
تزبط ولا
اذا بحط 0 دوت بحسب هيدا significant figure. yes. اذا بس بحط 0 دوت بحسبه significant.
اوكي، يعني بينما اذا بدي احط 0.00
100% اذا بحط 0.001 ما بحسب هول. اوكي، لانه هيدي الرول اذا بتشوفها قبل، هيدي اي نمبر يمكن هون قالوا لنا انه اذا عندنا zeros قبل يعني to the left ما بنحسبهم. let me check which rule. yeah, leading zeros are not significant. يعني هول ما بحسبهم. اذا بكتب 0.0032 اوكي ما بحسب ال 0.00، بحسب بس 3 و 2. بس اذا بس بحط 0.00 ساعتها بحسبهم. اوكي، يعني في فرق بين 0.00 هون if you count لانه ما في شيء بعدهم تحسبهم، يعني تحسب 1 2 3. اوكي، بس اذا في نمبر بعدهم ما بتحسبهم ك significant figures. اوكي، واذا بتحط just 0 dot يعني انت بدك تحسب الزيرو ك significant figures. you will count it as a significant figure.
لكن ليه حطوا وقت 0.54 انه بس عندنا 2 significant figures؟
لانه في شيء من بعده وفي شيء من بعده different than 0. اذا في شيء من بعده different than 0 ما بحسبه هيدا، ما بحسبه. اوكي،
ما اذا كمان اللي بعده 0 ما بحسبه.
نعم
مش اذا كمان اللي بعد البوينت يعني 0.00 ما بنحسبهم؟
مزبوط. لا، ما هي الفكرة، إذا 0.00 بس في شيء بعدهم، أوكي، بده يكون في نمبر بعدهم أنت ما تحسبيهم. إذا في نمبر بعدهم ما بتحسبيهم. بس إذا ما في شيء بعدهم، يعني هيدا النمبر ليش حطوا لي إياه؟ تيفرجوني إنه أنا I can measure up to this accuracy. يعني لاحظي هون عندك مثلا وقتها كان عندك 92.00، اوكي، هول حسبناهم لانه ما في، يعني هون ما في شيء من بعضهم، يعني اجباري حطوهم لمعنى معين فنعدهم. اوكي، يعني انا بس يكون في زيروز وراهم شيء ما بحسبهم. اذا عندي كثير زيروز بالاول ومن بعدهم ما في شيء، ما في نمبر، I don't count them. بس إذا عندي بس مثلا 0.000 هلا يعني هلا هي قليل تيجي تجي هيك 0.00 لأنه بس هي فكرة إنه إذا أنت عم تعملي measurement وعندك zero lengths وأنت عندك الرول تبعك كان measure up to 0.01 millimeter to indicate هالشيء. اوكي، فيك تقولي انه a zero length correspond to 0.00. So here's the number of in this case the number of figures هي لانه ما في شيء من بعدهم I will count them. بس بمجرد ما يجي number من بعدهم I don't consider these leading zeros.
يعني إذا 0.1 عندنا one significant figure.
Yes, إذا 0.1 عندنا one significant figure. Exactly. اوكي، يعني مثل فكره كمان هون الديسيمال، اذا عندي 540 بلا بوينت ما بحسب الزيرو، اذا عندي بوينت بحسبها. اوكي،
اوكي. هلا ما دام بالفحص اذا ما عم مثلا نعمل تلكيل للجواب ضروري نحط الجواب 0.00 هيك كانوا عم يعملوا الاستاذ.
هلا هي الفكره انه بالاكزام هو بس يعطيكم نمبرز، انتم بدكم تعطوا نفس النمبر اوف significant figures بالاجوبه. يعني مثلا اذا اعطيني انه الفيلوسيتي هي 23.4، يعني كم عندي significant numbers 1 2 3، يعني زي expect انه your result will be presented in as 3 significant numbers. اوكي،
يعني إذا طلع جوابي 2 بدي أحط 2.00.
هلا انا عاده ولا ما كانوا يعلقوا هالقد بالبروبلمز، كانوا بس يقولوا بالاكزامز بالمالتيبل تشويس. سوري، هو قال لكم انه المفروض حتى بالبروبلمز تلتزموا بهذا الشيء؟ لانه صراحه ولا مره كانوا يدققوا بالبروبلمز. ما بعرف اذا السنه اتس ديفرنت. هو قال لكم انه اذا عندي 3 significant figures طلع لي 2 لازم احط 2.00. يعني ما بعرف هو شو قايل لكم صراحه، بس انا ان جنرال ما كنا نعلق على هالقصص بالبروبلمز. كان يجي بالمالتيبل تشويس سؤال او سؤالين عن significant figures. هيدي هي. I don't know اذا السيستم changed او اذا يعني هو شو قال لكم وقت عملتوا البروبلمز؟ قال لكم انه بالبروبلمز لازم تلتزموا بهيدا الشيء. هلا عاده اذا كان integer number ما كنا خلص نحطه 2، يعني مش ضروري. بس انه اذا عندنا decimal points عرفتوا كنا نقول انه نحن عاده كنا ناخذ at least 2 3 numbers after the decimal point. هي هلا ما بعرف اذا هن مشددين على هالقصص هيدي السنه او لا، بس ما علمي يعني. I will check with Dr. نخول anyway، بس ما بعتقد يشيلوا لكم علامات على هيك قصص.
هو بس كان عم يحل بروبلمات، كان عم يعمل هيك، بس انه ما قالنا بقى.
كان عم بيكون كل النمبرز تبعه same number of significant figures يعني.
ايه
اوكي، طيب فاين. هلا انا جبنا الرولز وشفنا شو هن، صرنا نعرف نطبقهم. فاذا بدهم اذا طالبين هالشيء انه اتس فاين، منا هالبيج ديل يعني. اوكي، بعد في رول وحده Okay. For a number in scientific notation, all digits comprising n are significant by the first 6 rules. However, 10 and times are not significant. يعني إذا بكتب 5.02 times 10 to the power 4, okay, and I want to know what is the number of significant figures in this case, I don't count whole يعني times 10 to the power 4 ما بحسبها بالnumber of significant figures. I just consider إنه what is the number of significant figures of this number here. Okay, يعني مثلا 5.02 1 هيدا الزيرو بحسبه لأنه it's between two numbers. So 1 2 3. So the number of significant figures in this case is 3. وهيدا النوتيشن scientific notation فيكم بتخليكم تلعبوا بالnumber of significant figure as you like. يعني مثلا مثل ما قلنا إذا بكتب let's say 1 for example إذا بكتب 1000 dot okay قلنا إنه بحسب 1 2 3 4. فيني غيرها للنوتيشن إذا بكتبها 1 times 10 to the power 3 اوكي هيدي بتكون equivalent ل 1 significant figure. او فيني اكتبها كمان 1000 كمان بتكون 1 significant figure. يعني I can play with notation to change the number of significant figure I want. حسب النوتيشنز that I use. هيدي scientific notation بس بعد ساعتها number of significant figures here without counting 10 to the power 4. اوكي
مش لازم نرجع نحط 1.00 for 10
نعم
3.
لا إذا أنت بدك ما هي
1.00
الفكرة إذا أنت بدك تغير إنه إذا حطيت 1.000 times 10 to the power 3 شو بيصير النمبر of significant figures هون؟ هيدي النوتيشن قد ايه number of significant figures فيها؟ ساعتها بتحسب هول الزيرو.
4.
ايه 4. بينما إذا بتكتب بس 1 times 10 to the power 3 بس بتحسبها 1. وإذا بتحط 1000 دوت بتكون 4 وإذا بس بتحط 1000 بتكون 1. يعني هول كلهم نفس النمبر بس غيرت طريقة الكتيبة بيتغير النمبر of significant figures.
بس آخر سؤال شو أنا عايزة significant figure؟ ما فهمت بعد شو قصتها.
لا اوكي ليك هي اكثر شيء لها عازه خصوصي بالاكسبيرمنتس اكثر من انه هلا كمان لها عازه انه بطريقه الكتيبه فيك تفهم انت كم ب certain problem of calculation قد لازم تعطي number of significant figures. بس هي اهميتها اكثر مثلا بالاكسبيرمنتس بالmeasurements. يعني if I give you a device if I talking about a device وبقول لك انه I'm measuring velocity اذا بقول لك velocity measured is 1.000 او بقول لك the meter per second او بقول لك انه the velocity measured is 1 meter per second. شو الفرق بالنسبه لك؟ بالنسبه لك عم تقول لي انت انه نفس الشيء ما اثنينهم 1. الفرق انه بيعطيك النمبر accuracy of measurement of your device. يعني اذا الديفايس تبعك is able to measure up to 0.001 meter per second ساعتها هيدي النوتيشن بتفرجيك انه الاكيورسي تبعها is of the order of 10 minus 3 meters per second. بينما اذا بس بقول لك 1 meter per second انت بتفهم انه I'm just الاكيورسي تبعها هي of the order of 1 meter per second. واذا بقول لك انه الديفايس is measuring 1.00 يعني بتفهم انه هو بيقدر يعطيني accuracy up to 0.01 meter per second. يعني number of significant figure is an indication of the accuracy of a certain device. أو كمان in a certain problem is an indication about the number of significant figures that you should use in the problem. يعني مثل ما كان عم بيعلمكم بالproblems.
اوكي بس نعرف انه حيطلع جواب صغير.
هلا قصه جواب صغير يعني هو تيقول لك اذا بدك ايه
معقول يطلع فالفيلات هالقد.
هلا هو عاده بالبروبلمز بناخذ 3 4 significant figures. يعني مثلا اذا بيعطيك انه الفيلوسيتي is 1.52 يعني انت كل اجوبتك فيك just to give 3 significant figures مش اكثر. يعني لو الكالكوليتر عطتك values اكثر انت بتوقف على third significant figure لانه انت انطلقت من بالgiven يعني number of significant figures is 3.
ديل.
Okay, other questions on significant figures? طيب هلا يمكن ما بعرف maybe الايميل ما وصل يمكن because of the size I will check. حابعت لكم زيادة عن هوليك الفولدرز this one to remind you of the rules of significant figures. Now I will do with you some problems on statics to refresh your mind about equilibrium. static equilibrium لأنه بالproblems اللي عطيتكم إياهم في some static problems. So let us do together some problems on equilibrium. Okay, I will start first. أنا بالصف حكيتكم عن equilibrium of a rigid body, and I told you that whenever you have a body, you can write two conditions for equilibrium: sum of forces equals to 0 and sum of moments equal to 0. هيدا the more complex scenario. But the easiest one is when you have just particles. So when you have just particles, it's much easier. لأنه already sum of moment is equal to 0. يعني you just have to deal with sum of forces equals to 0. Okay. So let us see here how we can solve this problem using just the concept of equilibrium of a particle. So by just applying this relation, we can solve for all tensions in this problem. So in this example, we have a body. We give the mass of the body. The mass of the body is given. And هلا هيدي English unit. نحن عادة ما بيعطوكم SI units, but just be familiar with all units because the English system of units is widely used. So when you see slug, this is English unit for mass. يعني بدل kilogram, it's in slug. Okay. Now, so they gave us the weight. Okay. We know the weight is mg, and we want to find the tension in all cables to maintain this box in equilibrium. If you look at this problem here, from where you can think to start? If I want to solve for all tensions, بأي cable أهين شيء بلش فيه؟ So let me number my cables. This is cable 1. This is cable 2. This is 3, 4, and 5. So I have 5 cables, okay? And I want to measure tension or calculate tension in all of these cables. If I just look at my figure, I know information about the weight. So this is what I know. This is why I can try to start from the block, okay? If my block is in equilibrium, if I draw the free body diagram of my block, what are the forces acting on it? The weight of this block and the tension in cable 1T1. So to have equilibrium, what is the condition? That T1 should be equal to W. Okay, so now I am done with T1. This is equal to M times G. Now, once I know the tension in this cable, I can see that this point is a connection point between 3 cables. And since this point is in equilibrium, so sum of forces on C is equal to 0. Okay, and because it's a 2D problem, بس تكتبوا الvectorial relation sum of forces vectors on point C equals to 0, you can decompose this vectorial relation into 2 equations, one in X and one in Y. So you can solve up to 2 unknowns. Okay, what are your 2 unknowns here? You got already the tension in cable 1, so you still have to find tension in 2 and tension in 3. Okay, so let us project forces along X and Y to get what is T2 and what is T3. So to do this, you take a frame. We can take X and Y, the horizontal and vertical components. And now we say sum of forces at C equals to 0 because C is in equilibrium. So first, the first equation is to project along X. Sum of forces along X equals. To be able to project, you should draw first your forces. You should present the free body diagram of forces. What are the forces acting on C? You have this tension. ليش عملت arrow upward? Because look, for any cable, this cable is between 2 points, okay? This one and this one. If I call هلا هن مسميين C إذا بدكم الكابل, so let me call this points E and F, okay? E, F, and this is cable C, okay? If the cable C, keep in mind a cable can never sustain compression. A cable is always subjected to tension. لأنه ما بيتحمل compression. إذا عملنا compression عليه, it will deform, okay? So for a cable in equilibrium conditions, it can only be subjected to tension. Is a cable in tension, this means what? This means that E is pulling it down and point F is acting on it up, okay? So this is the action of, this is the force of the point E on the cable. But when I take point E as system, this point here, so this is the force of the point on cable. When I take the point as my system, who will be serial point of interest? يعني أنا ما بدي أجيب الpoint force of point on cable. I need to determine what is the force of the cable on the point. And you know that by action reaction, if the point is pulling the cable downward, then the cable will pull the point, will push it up, okay? So this is why always, because a cable is always in tension, its action on the points is always towards the cable. Yani, when I take this point, okay, the cable is acting on it towards it, هيك. While if I take this point, the cable بيشد بهيدا الpoint like this. So always in opposition to the action of points on the cables which are outward from the cable. This is a very important concept, okay? If you understand it, then you can calculate tensions in a very simple way. And once you take now point, this point here, we can call it E, okay? 1 second. Okay, so when you draw the free body diagram of this point, you will say that since my cable is in tension, all my cables are in tension, then they will act on this point, all will act towards the cables. So the three forces will be directed in this way, from the point towards the cables. Now, I already determined that this force is equal to the weight. So in this cable will push the point downward with a force equal to the weight. I still have to get what is the tension in D and what is the tension in C. To find the tension in these cables, I should project. I have two unknowns. I project on Y, I project on X. Okay? Now, if I start by projecting along Y direction, what do I have? I have a positive projection for the tension in cable C. And since this angle here is 60 degrees, so this component is the tension in C times sine 60. Now, since cable D is horizontal, so it doesn't have a component along Y, then it's 0 along Y. And finally, I have the weight that is downward, so minus the weight equals to 0. Okay, هلا بس انتبهوا هون وقت نحكي بإنجلش system ما بنضرب ب 10. In English system G is not 10, G is 32.2. فإذا شي مرة مرق معكم English system, just keep in mind إنه G is not in meter per second square. I deal then with feet per second square. And the value is not 10, it's 32.2. This is why here, if you multiply 76 by 32.2, you get that your weight is 2,447. Okay? So here, the first equation will give us the tension in cable C. Now, I still need to get what is the tension in cable D. To get the tension in cable D, I apply now sum of forces along X direction. So if I take the X direction, sum of forces along X equals 0. First, the weight has no projection along X. D is along negative X, so it's minus D. And C has a positive projection on X. And to get this positive projection, I do plus C cosine 60. So I already found C from the previous step. I replace C magnitude here, and I can get the magnitude of the tension in cable D. Okay. Now, once I am done with this point, I know now the tension here, the tension here, and the tension here. I still have two unknowns. What is the tension in cable A, and what is the tension in cable B? To find these two tensions, what is the point now of interest? The point of intersection of these two forces. This point, I can call it F. Now, to be able to get the tension in cable A and the tension in cable B, I should do sum of forces on this point. Okay, so to do it, I need to draw the free body diagram. The rule is always the same. The cables are always in tension, so they will act on a point from the point towards the cable. So the force of A, of cable A on this point, on point E, or point F, let us call it, is from the point towards the cable. This is tension in A. Because F is pulling the cable down, so the cable will push F up. Now, concerning cable B, same concept. B will do a force on F upward, because F is doing on B an action that is downward. And for this cable here, this cable is pushing the point downward. So these are the three forces acting at F. I know already the force in cable C. You know that for one cable, wherever I do a cut, the tension is the same. Okay, so since you already calculated the tension in C from previous step, you will take the same value, which is 2,826. Just you should pay attention that here the force was up because I was considering the force of cable on point E. And now, because I'm considering the other point, the other extreme point F, the force will be same magnitude but down. Okay, so now once you present your forces and you know their angles, you know that the force in B is doing an angle of 30 degrees with the horizontal. The force in A is doing an angle of 40 degrees, while the force in C, if you look at your figure, this angle and this one are alternating angle. So this angle here is 60 degrees. So now, since you know all your directions, you just have as unknown the magnitude of tension in A and the magnitude of tension in B. So you have to write two equations, which will be sum of forces along X on point F equals 0, and sum of forces along Y on point F is also 0. So let us do the projections together. This is the figure of the free body diagram. So always you should represent first your free body diagram. You represent the free body diagram of this point, showing